answers to that page. So what I do is I kind of list, why is this moving so much here? I don't know. If it's a positive here, you know that these both have to be negative or these both have to be positive, right? But if you have a negative number last, then one has to be positive and one has to be negative. That was the trinomials. So whenever you've got a trinomial, just means there are three terms. I don't know why this is shaking so bad right now, but must be having our building is shaking. So when there's three terms and it starts with x squared, you can use this strategy of the diamond. So what you want to be on the lookout for is first, I look for a greatest common factor. If I can't do that, I look for the difference of squares. Basically, if you see some of these perfect squares, that should like trigger a red light in your brain, like, ooh, or a green light maybe, like, oh, difference of squares, I'm using that pattern. Everything else is probably going to be a trinomial. So all you need to look at is the x squared term. And if there's just a 1 in front of the x squared, you're going to use the diamond. So the back page of this, I was going to show you the box method and the grouping method on the same problems so that you could pick which method you like best. I'm not sure which method you came from, or if you all learned the box method or you all learned the grouping method, but I'll show you both and you can pick which one you like for some of the practice problems. So how are these problems different? Now I have a 3x squared or a 2x squared. So see how it's the leading coefficient needs to be a different number other than 1. All right, so here I am. I'm going to do the box method first. And if you don't like the box method, maybe you like the grouping method. So the box method takes a 2 by 2 box and you're going to put the terms into this box. So 3x squared always goes in the top left, and your constant, which is -5, always goes in the bottom right. Now, I only have this -14x. That has to get split up into these other two boxes, but I need to do it the correct way. So how am I going to split up the -14x's? I actually am going to do the diamond method before I do the box method. And this is a little bit trickier than the other diamond method. This time, you need to take your A value of 3 times your C value of -5. Before, we didn't really have to worry about our A value because our A value up to this point has always been what number? 1, right? So it's always been 1 times C. But right now, we have to multiply the A and the C values together. So that would be -15. I still put that -14 down at the bottom. So now I'm just looking at the diamond method. What are the factors of -15 that add up to the -14? Yes, so -15 times 1 is -15, but those two add up to the -14. Does that kind of make sense? I did the diamond method. I'm going to put these two terms inside my box now. So I have -15x and I have 1x. So this box is equivalent to that first trinomial. I have 3x squared, I have -14x's, and I have -5. Setting up the box is the hardest part. Now you're going to pretend you're multiplying and finding area, and you have to say what goes on those outside parts of the box. So what times what would give me 3x squared? X times 3x. So I either need to put the x term here or the x term here, and the 3x here and the 3x here. Do you see how this is across from this -15x? So I actually want to put the 3x on this side and then the x up top. That way I can figure out the rest of my box. You'll figure out if you need to flip them around because it won't work. So it only goes in one way. So now I need to put the 3x times what to get the -15x right here? It would have to be -5, right? So one of my factors is going to be x minus 5. And then what's going to go down here? So this x up top times 1 would give me the 1x. So this is my other binomial. You can always check that this -5 times this +1 should come out to this -5. So So your answer is 3x plus 1 and then x minus 5. So who feels like maybe box was the way they learned how to factor? A lot of you? Maybe. I want to just show you this same problem using grouping, and then you can pick one of the methods to maybe try example B. Because I'm not going to force you to learn both of the ways, but all right, so this is the same exact problem, right? You have to do this first step on either problem. So my first step is to use the diamond to figure out these basically other two boxes. Instead of writing it in box format, you write it out as a line. So 3x squared minus 15x plus 1x minus 5. It doesn't matter which order you put your negative 15x and your positive 1x in. So you could have those flip-flopped, but this is the same set of 4 terms that I had up here inside my box. So on both methods, you have to find your 4 terms. So on grouping, what you do is you group together the first 2 terms and the last 2 terms, and you look for the greatest common factor. So what could I divide out of this first parenthesis? I can divide out a 3x. So if I have a 3x, what do I get from this parenthesis when I divide by 3x? I get x minus 5. Okay, because I get the x from this term, the negative 5 from this term. Now, you might say that this doesn't have a greatest common factor, but everything has at least a greatest common factor of 1. So I can divide out a 1 from this parenthesis, and I get x minus 5. You did something right if these come out the same. So one of your factors is x minus 5. And what would you have left? If you divide out x minus 5, the only thing I haven't used here is this 3x and this 1. So my other factor would be 3x plus 1. And see how those are the same exact factors that you got on the outside of your box. So let's set up our 4 terms, and then you decide, I'm going to practice the box method a lot, or I'm going to practice the grouping method a lot. All right, but getting the 4 terms is the important step that we need to practice. So I'm just going to set them up inside the box for now, just so I have somewhere to put my terms. But I'm going to put 2x squared here, positive 4 here. I need to find out how to split up that 9x. So when I do the diamond, I do 2 times 4 is 8. And then the 9 goes on the bottom of the diamond. All right, so what are the factors of 8? So I want 1 times 8 or 2 times 4. I'm trying to add up to 9. So I want 1 times 8. So I'm going to put 1x and 8x. And I can either solve that box, or I can write out down below that, but I'm going to do it by grouping. 2x squared plus 1x plus 8x plus 4. So see if you can attack one of those now that I set them up. I'll put up both answers in just a minute, but see if you can try the box strategy or the grouping strategy to get to the final answer. All right, so I wanted to take a look at these 4 problems, because 2 and 3 we're doing like grouping or the box method, right? So we always start by looking for a greatest common factor. There's no greatest common factor. So now choose, your method, but I tend to just set up the box to kind of hold my numbers. So I've got 2x squared and I've got a 12. I need to figure out my other 2 numbers by using the diamond method. And I do 2 times 12 is 24. And I need the factors to add up to 11. So what are the 2 factors I should try to use? This one has a lot of factors, right? 24. The 11 is coming from here, right? They add up. Right, but 24 is a lot of factors. So if you wanted to start listing the factors of 24, it might help you if you just list them. Divide it on a calculator, then you might see, oh, 3 and 8 adds up to 11. So I want to use 3 and 8 as my other 2 terms. It doesn't matter. You could flip-flop them. You'll still get to the same answer, but your box will look a little bit different. So you can either try the box or try the grouping method. If you want to just list them out in a line, you would do 2x squared plus 3x plus 8x plus 12 in a line and group them together. So see if you can get, is that the hard part of setting it up, and then hopefully you can use one of the methods to get to the final answer, or is the actual method the hard part? Oh, yeah. At the very end. So what were our factors? We said x plus 4 and then 2x plus 3 equals 0. What will make this factor 0 and what will make this factor 0? So you're actually finding an x value that will make that equation true. What does x have to be here? Negative 4. This one's a little bit harder to do in your head. So when you're just kind of learning this, you know, that one you might do really easy in your head. You might want to write out for yourself the equation, what will make 2x plus 3 equal 0, and then do the algebra. Subtract 3 to the other side. So 2x equals negative 3, and then divide by 2 on both sides. So x equals negative 3 halves, or negative 1.5. So that's actually a pretty challenging problem to get all the way through the factoring and solving. By tomorrow, yeah. We'll practice it more tomorrow. Like this whole page over here is all set equal to 0. I don't think we'll quite get to that part today. Let's take a look at number 2, setting it up together, and then maybe you can try doing your method and getting the final answer of x equals whatever. I'm going to set it up as a box. If you want to do grouping, that's great too. So 3x squared, negative 15. My diamond this time is a big number. 3 times negative 15 is negative 45. And my middle number is 4. So you're looking for the factors of 45. Divide it by 1 in your head. Divide it by 2 or 3 or 4 or 5. You can use a calculator. So if you're not sure the factors of 45, start typing in, what is 45 divided by 3? What is 45 divided by 4? What is 45 divided by 5? Can anyone think of what the correct set of factors are? It is 9 times 5, but you want to use negative 5, right? 9 and negative 5. That would add up to 4. So I'm going to throw that 9x and negative 5x in one of the two boxes. It doesn't matter which one, it'll work itself out. But depending on which box I throw the 9x in, right, this is going to be a 3x times an x over here. So you want to line that up to match up with the 9x. So see if on number 2 you can practice factoring that. So I'd want to put the 3x alongside where that 9x goes, right? If I put the 3x up here, I can never get to negative 5. So the 3x has to go across from the 9x. So it'd be x plus 3, because 3 times 3 gives you the 9. And then x times negative 5 to get the negative 5x. So let's practice. How do I solve this for 0? I've got x plus 3 times 3x minus 5 equals 0. So I've got my two factors. Now I need to come up with my actual solution. The first one's easy. What would x have to be in this first parenthesis to make that 0? X just has to be negative 3. So you should be able to see that without much trouble. This one's a little bit harder. So what will make 3x minus 5 equals 0. What do I do to get x by itself? So solve that for me. How do I get x by itself? Add 5 to both sides. So 3x equals 5. And then divide by 3 to get x by itself. So I would just leave it as 5/3. X is either 5/3, which is 1 2/3, or x is -3. I just want to show you on the graph of a quadratic, these are the x-intercepts. So 3x squared plus 4x minus 15. So this is the graph of number 2. There's one x-intercept, right at -3. The other x-intercept is at 1 2/3. So the x-intercepts on the graph are the solutions that you're finding by factoring, right? Because an x-intercept, the y value is always 0. The y value is equal to 0. Let's do these two more together, and then I might have you try maybe one on the back on your own. Now, number 3 is not a trinomial anymore, right? It's only a binomial. What are the strategies that we could use for a binomial? What should I always look for first? A greatest common factor. Can I divide something out of that problem? A 5 and what else? How about an x? Can I divide out a 5x in this problem? Yeah. So if I divide by 5x, what will I have left inside this parentheses? X squared minus 25. I see something else that can now get factored one step further. What is this called? This is a difference of squares, right? So you want to start recognizing when is it a greatest common factor, and hey, this can go one step further. Difference of squares. Take the square root of each part, put one with a plus and one with a minus. So I would have 5x with an x plus 5 and an x minus 5. This is a cubic function. See how it says x cubed up here? It's going to have 3 x-intercepts. So what are my 3 x-intercepts? What will make these parentheses equal 0? -5, +5, and 5 times what will give me 0 over here on the left? 0. 0, -5, and 5. And if I actually graph this function for you, 5x cubed minus 125x, we should expect to see, so there's an x-intercept at -5, 0, and 5. It's a big squiggle graph, but you can't see it. I got to zoom out. Number 4, what kind of function is number 4? It's kind of hard to see because I've already written on my paper, but it's a quadratic. Does it have a difference of squares? 4x squared, right? And 9. It's a difference of squares. So to write it as a difference of squares, you take the square root of each part. So 4x squared is what times what? 2x times 2x. And what about 9? 3 times 3. And 1 gets a plus and 1 gets a minus. See if you can solve for the 2 solutions to that. What does x have to be? You probably have to write out the equation. What will make 2x plus 3 equal 0? What will make 2x minus 3 equal 0? See if you can come up with your 2 of 3. Divide by 2. So x would equal -3/2 for my first. And if you're kind of paying attention, guess what? These are just opposite in sign. So your 2 solutions are going to be +3/2 and -3/2, right? Because this would add 3 to the other side and divide by 2. And those will show up as your x-intercepts. So let me just pick one more problem from the back page, and I don't think I can pick the first one because I think it's prime. Oh no, there's something else that I need to do. Why don't you try Example number 11. This one's a little bit different. This one they actually wrote out with the 4 pieces for you to do grouping. But if you've been practicing the box method, you can just stick your 4 pieces inside the box. 2x squared minus 6x plus x minus 3. So could everyone try number 11 as our last problem today? And you actually have to find your factors and solve your factors. So like x equals 7 and negative 1/2 or something. See if you can do 11 as the last one. Either do grouping here or box method here and find yours. And we'll do some more practice tomorrow, do some graphing practice, do a bunch of factoring practice. I have a couple other factoring strategies that'll be new for